Okay, let's start. Can you hear me?
They can hear.
Yeah.
Okay. Hello, everyone. Welcome to TRON Core Devs Meeting. This is meeting number 9. Let's get started on the agenda. So first, Zachary will introduce the latest update from Java TRON. And this time, we are very honored to have invited Matthew, the lead of TRON team, so to give us an introduction on TRON's shielded contract to the TIP 135, 137, and 138. Okay, we'll move to the first topic. Hello, Zachary. Ready to start your part?
Hello. Can you hear me?
Yes.
Yeah, well, so key update is the version 4. This hard version and proposal 40 will be put forward to use TPost as the block consensus method. And along with 4.1, the light node have mentioned about this for several times before. This will be available this time. And at the time a light node starts, it only retains about 50,000 blocks. And this saves dozens of times of the disk space. Okay. And also we will provide a Dockerized solution for full nodes. And I believe this can reduce much development. Yes.
Sorry, Zachary, your voice is a little broken. Can you repeat the first two items?
The first, you mean the
first two items you just mentioned.
Yeah, the first is the 4.1 is a hard fork version, and there will be proposal 40. Proposal 40 is about we'll use TPost, the new block method. Is it clear?
Better.
I think work is not right now.
Okay. Okay, Zachary. You guys have any question regarding this part?
No, here. I have been following this updates here.
Sorry, then.
I'm sorry about my network. So can you type that out? I cannot hear you clearly.
We're just that your studio, you can hear what you say, and I think everything is good. You can go.
Sorry, Crypto Chain. So your voice is kind of broken. We cannot hear you.
I can hear what Chen says. He told us that he could hear loud and clear, and we may proceed.
All right. Yes.
Okay, thanks, Zachary. Let's move to the next. Let's move to the next topic. Let's welcome Matthew.
Right. Hello everyone. So my name is Matthew To, lead in TRON's team. And joining me today with Federal and Lee as well. So well, first of all, let me share my PowerPoint first. Okay. Okay. Can everyone my slides?
Yes, I can see.
Okay. So let me introduce you TRON. So a group of experienced TRON community developers, especially in cryptography. And our goal is to provide privacy and better security to the TRON ecosystem. for some of you may know, we already brought the shielded contract and shielded transaction into TRON at TRON 4.0. And today, let us introduce, oops, sorry. I forgot to close the ring. Yeah. Let us introduce the knowledge proof inside our virtual machine today. So let's start by what is zero knowledge proof. I'm sure that many of you might have heard of the term zero knowledge proof a lot, but what exactly is? It is a method by which one party can prove to another party that something is true, yet without revealing any information apart from the fact that this specific statement is true. So let's say you want to prove that you have $1 million, and the verifier will ask you, well, show me your $1 million, please. But instead of showing to the verifier that your $1 million, you have some other methods to prove it. So let's say you could prove that by showing off your credit card from bank, or your luxury car, yacht, private jet, or your big house, name it. So of course it would be a different story technically, but you get the idea behind it. And all of the zero knowledge proof has the following three properties. The first one is if the statement is true, then the honest verifier will be convinced by the fact that it is an honest prover. Second, if the statement is false, then no cheating prover can convince the honest verifier that it is true, well, except with some small probability, which we call the soundless error. And finally, if the statement is true and no verifier learns anything other than the fact that the statement is true. So that is the fundamental of the zero knowledge proof. And over the decades, numerous research were already proposed about zero knowledge proof. And now there are three major knowledge proof methods which are widely using in the blockchain industry. The bulletproof CK stacks, which is knowledge scalable, transparent arguments of knowledge, and CK snarks, the zero knowledge succinct, non-interactive arguments of knowledge. And among the three of them, we took the CK snarks as our implementation approach. And here's when you look to different properties of the proof, well, you can see that CK snarks has the smallest proof size compared to CK stacks and bulletproof. And again, in terms of the verification time, CK snarks perform the best as well. And while there are some compromises on the proof time, which is like 40% more than that of CK stacks, and also it is the only method which requires a trust setup, but we believe that using the CK snarks would provide the best user experience to TRON. So therefore, we think it is the best method to pick. And underneath the CK snark scheme, it involves a lot of complex cryptographic theory, which I'm not going to go through all the process one by one here today. But the basic idea is like this. You want to transform a statement, something that you want to prove, for example, like I know the keys that allow me to spend a shielded transaction, turns it into an equivalent form of a quadratic arithmetic program. And the prover has to show that he or she knows the solution of this program. And then therefore he will have the right to spend the shielded token. Well, so zero knowledge proof can play a key role for privacy protection in blockchain. and it can be used to prove that the conditions of the valid transaction has been met without revealing anything. So it's more and more important right now. And now let's talk about the shielded transaction protocol. And we have to apply the shielded account system, which is quite different from our ordinary account. We have a bunch of keys to create in order to perform of operations. But all the derived from one single key, as you could tell from the picture, and all serves the purpose throughout the process. Maybe some of the may involve more operations, some of the keys are from two keys. What you get here? While it seems very complicated and troublesome to through all the apps and all these different keys, but we've prepared one single API for you, which is the get new shielded address. You call this API in your JavaTron node and simply call it, then you will have all the keys that I've just mentioned, and in addition, with a shielded payment address as well. And the shielded transaction protocol is based on the unspent transaction output model, which is UTXO model in short. That is the same protocol that were used in the Bitcoin. Each shielded output is a node in which the node consists of a payment address, the transaction amount, and a random number. So when a user spends a node, he needs to first generate the spend description with the listed inputs. But one thing I want to highlight is that we only put the commitment of the value onto the chain, not the value itself, and therefore it could provide a better privacy for users. The same goes to the shielded output as well. It needs to generate a received description. And you see there are some similarities here. The purpose of putting the node commitment instead of the node itself on chain is the same as that of the value commitment. With both the spend description and the receipt description, they forms the input and output of a transaction respectively. And with each transaction linked to one another, it forms the whole unspent transaction output model. Well, with the shielded transaction protocol defined, we then go to the shielded TRC20 contract. So it is introduced in TIP 135, and the purpose of it is to implement the functions to hide the source address, destination address, and also the token amounts for the TRC20 transactions. Well, with all this information hidden, then you could call it as shielded, right? And we do that by implementing three core functions, which is the mint, transfer, and burn function. First, the mint function is to transform a public TRC20 token into a shielded token, and therefore it has one transparent input and one transparent output. For transfer, it is used for the shielded token transactions, which you could hide the source address, destination address, and also the transaction amount. And you could put up to 2 transactions with each transfer call. And therefore, you will have up to 2 shielded input and also 2 shielded output. Finally, the burn function is to transform the shielded token back into the public TRC20 token. Therefore, it has one shielded input, one transparent output. And based on different scenarios, you might also have one shielded output as well. And well, it would be easier for you to understand the whole picture when you look at the flow diagram. So let's say we have Alex and Bob here, And Alice owns 100 just token, and she want to pass these tokens to Bob secrets. Neither one of them would let people know what they are doing. So Alice would mint just token, then the just token will become shielded in the shielded TRC22 contract. And then you may also perform some transfer process in the contract. Now, Bob, Bob can burn the token back to the public form, and therefore the transaction is completed. Nobody would know that there are transactions between Alice and Bob. So that is the idea of how you use the three core functions that we just used. Also,
sorry to interrupt. I got my question. So, is this shield transaction applicable for all standard TRC20 tokens?
oh yes, it is applicable to all the TRC20 token. And if you want to shield some your original TRC contract, you bind your contract address into the shielded TRC20 contract when deploying shielded contract, and then you are good.
Okay, thanks.
Mm-hmm. Oh, I have to redo the animation. Now, with all the three core functions implemented, as it is based on the zero knowledge proof, and there are some complex verification process we have to implement as well. And therefore, we also introduce four functions in order to speed up the process in TIP 137 and 138. As you could see here, there are three verified proof instructions to verify the proof of the mint, transfer, and burn function respectively, with an additional pedersen hash instruction as well. So like a TRC20 contract, it has a set of protocol which you have to follow. And by implementing these three verified proof instructions, they also create the standard of how a shielded contract should be. And therefore, they could all cover all the transaction which would happen inside the shielded contract. And you need to have all three functions verified, which is mint, transfer, burn functions, in order to get your shielded contract complete. And all these verified proof functions only take about 10 milliseconds. So it won't cost you a lot of time. And one addition is that we also implement the pedersen hash instruction. It will help you to compute the node value inside the Merkle tree, and also return a node value, which is the parent node value. And it may support a Merkle tree up to a depth of 64, but in shielded transaction, we use a 32-level Merkle tree. And again, it's just super efficient. It only costs less than 1 millisecond this time. Well, for more details about the verified proof instructions and also the pedersen hash instruction, you may proceed to TIP 137 and 138 for more details. The use case are clearly listed inside this TIP. Oh, also the TIP 135, it's also listed how you should use the mint, transfer, and proof function, burn function as well. Well, as said in the beginning, our CK snark method need a trusted setup as well. And therefore, we organized the multi-party computation torch project back in June. And it is initiated by us, of course. And it is officially launched by Justin Sun, the founder of Tron himself. Well, which is an honor. And you could see Justin Sun himself did participated in this torch project. And there are by far 196 participants, including developers around the Tron community, blockchain enthusiasts, those from the traditional industry, the daily active users, and also some KOLs. So Torch is by far the most participated MPC project by numbers around the blockchain industry. So I would say it is quite successful. Well, maybe that's it. So we've already set up the whole picture of how we implemented the zero knowledge proof inside Tron. And let us now compare our solution with some other famous zero knowledge proof projects within the blockchain industry. Well, the first one is the Monero. Well, Monero has a medium range in privacy and complexity. It uses a ring city protocol, but the ring size is linear with the linear with its ring size, and it uses a bulletproof method. Well, if you remember at the beginning of this introduction, we've mentioned that bulletproof method is a very poor performance zero knowledge proof method, and therefore it has a poor performance. The second one is Zcash. Well, many of us will already know that its privacy is perfect, okay, but it's also very complex. Same as us, it uses the ZK snarks, but doesn't support the shielded contract, and therefore it has a very limited extension in terms of privacy. Brin, with a medium privacy and also a low complexity. It uses a Mimble-Wimble protocol and with a pedersen commitment. It can hide the transaction amount as well, but it requires the sender and receiver to have some interaction beforehand. So it is not very convenient. And again, it uses a bulletproof method, and therefore it performs very poor as well. And Tornado Cash, a very pretty famous mixer solution on the Ethereum blockchain, and it is quite complex actually, but it supports the shielded contract like us. But if you try to go to their user interface, you know that you could only deposit and withdraw a dedicated amount of token. So let's say if you want to transfer 2 tokens to your friend, you'll have to do them. You will have to do 2 times because it only supports sending Ethereum 1 by 1 or 0.1 or 0.01 and so on and so forth. Okay, it is a dedicated amount, so it is not that convenient. And also, as you know, the mixed solution the privacy is proportional to the number of active users. So let's say you could imagine if there's only 1 or 2 people using the mixer, then it's pretty easy for the people outside to guess and find out who is exactly doing transactions with who. Then what's the point of using it, right? And AZ tag, again, it supports shielded amount, but it 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 will generate a one-time public address for the sender and receiver, so the privacy is not that high actually. And if you compare to our shielded TLC20 contract, it has the privacy level as high as that of Zcash, yet it has a great performance, low transaction fee, and it is extendable with smart contract because it is a shielded TLC20 contract, right? And it is by far, we won't say it's the most convenient, but it's more convenient than most of the other projects out there. So And well, I think that's it. Let us share our vision. We are devoted to the research of frontier cryptographic technique and want to make a contribution for the privacy protection in blockchain. So whenever there are new things coming out in the blockchain industry, we would try our best to study it, dig into it, and bring it to the blockchain as fast as we can. And we have a lot of plans as well. So we would want to launch this CK rollup, which is to improve the scalability of the blockchain. And also we are trying to build a virtual machine, which the general purpose of privacy protection scheme in the apps. So we would like to implement more multi-party secure computation. More is yet to come. So I think that's it. I hope all of you could get something from my introduction. Hope you will enjoy the time. And if you are interested in zero knowledge proof and also want to try out the shielded transaction, just don't wait and try out these features in the TRON. So thank you for listening.
Thanks, Matthew. Do you guys have any question regarding the shielded contract?
Hello, Matthew.
Hello, I can hear you.
You said the shared transaction is very time consuming. Maybe it will affect the normal transactions. I want to know how many shared transactions can be packed into one block. Is there any limitation?
Okay, so currently there are no limitation for the number of shielded transactions to be packed inside a block. It would be decided by the block capacity itself. Yeah. And if you're asking about the will the shielded transaction takes a pretty long time and it will affect the transaction per speed inside the Tron community? Well, I would say that it is as fast as the ordinary transaction, and it only takes a few seconds, and therefore it has no influence to the transaction per speed at all. And also, uh, it's like the multi-sign feature as well. So we provide the feature, right, but they are all optional. So for most scenarios, people would be okay with the ordinary transaction, and the of course there are some drawbacks, but not all people would use shielded transaction, and therefore it will not influence the whole blockchain size a lot, we believe. But the feature is there, so you may decide whether to use it or not.
Okay, thanks.
Okay, thanks, Matthew. So next, Liu will give us a demonstration on how to do mint and transfer via the wallet to just show us how to use the shielded transaction. Okay, Liu, will you start?
Okay. Hello, everyone. Do you hear me clearly?
Yes.
I'm Leo from TRON team. Next, I want to show how to perform a shielded transfer using our wallet client. We connect the wallet client to the Nile testnet. So first, we edit the config file. And here, this is the full node of our Nile testnet. And last, this is the item that we want to use. This item is used in the shielded transaction. it is commanded that the field is set to the block number in which the earliest relevant shielded contract was created. Because we use it in the naive testnet, so we set this number to 8,556,000. This number is that we deploy the shielded contract. Okay, let's begin. Let's open the what's called. First, we log in. Log in with a public account. We input the password. This public account should have enough TRX to trigger contract. And let's perform the shielded transfer. First, we use this command to select the TRC20 contract and the shielded contract. This command needs two parameters, and one is TRC20 contract address, and the second is the shielded contract address. So I copy the two address. This is the TRC20 contract address, and this is the shielded contract address. Sorry, network is not so well. This command will trigger the contract and get the scaling factor in the shielded contract. Okay, it is succeed. And the scaling factor is 1. And no matter you mint transfer of 1, the value must be the integer multiple of 1. And the scaling factor is set when the shielded contract was deployed. So let's load the shielded wallet. Oh, it failed. Because the shielded TRC20 wallet does not exist. We can use import shielded TRC20 wallet command to import the shielded wallet, or we can use generate shielded TRC20 address to generate one. So here we use the generate shielded TRC20 address, and this command needs at most one parameter. If you don't input any parameter, it will create one. And here you put the password, and the password is the shielded wallet. And then you put the password again. Okay. Network is not so well. Command will call the API of our full node. And this command, this command just generate one address. If you want to generate any address at a time, you just input the number as the parameter. Okay, it generates the shielded address successfully. And this is the shielded address. And if you want to generate two shielded address at a time, you just input 2. Wait for a minute. And this is the first shielded address. And this is the second shielded address. Look, there are 3 addresses, 3 shielded addresses. You can use this command, list shielded TRC20 address, to show the address in your local shielded wallet. There are 3 addresses. Now we perform the shielded transfer, and the shielded transfer all the three shared transfer, mint, transfer, and burn, are all done through this command. Send shared TRC20 coin, and this command needs many parameters. Next, I will explain the meaning of each parameter by performing a mint. Mint means that we transform a public token to a shared one, and we want to mint 1 million token from this public amount to a shared address and shared TRC20 coin. We want to send the 1 million token to this the last one address. So the first parameter is from public amount. We set 1 million, 2, 3, 4, 5, 6. And next, the shared input name. It is number of shared input because this is a mint transfer, so we set 0. And the next, input 1 and input 2. Because this is a mint, there is no shared input, so we can ignore these two parameters. And the next is the public to address, because there is no public output in this transaction, so we set none. And then the two public amounts also set 0. And the next is the number of shared output, because the mint supports at most 1 shared output, so we set it 1. And the shared address, we copy it. And we set the amount of the shared node, and it must be equal to this amount. 1 million, 1, 2, 3, 4, 5, 6. And the last is a memo. You can leave a message to the receiver by this memo field. If you don't want to set this field, you can set it to none. But we leave a message, mint 1 million. We have inputted password twice at the mint transaction because the first one is to trigger the approve function in the TRC20 contract, and the second one is to trigger the mint function in the shared contract, and the two passwords should be the same public account. That means you must use the same public account to trigger these two transactions. Okay, let's check this transaction by get transaction info by ID. Okay, here is the result. It looks success. Here, we can use list shared TRC20 node to show the shared output node. And this is a shared node we just sent. The first field is 0. That means the index of this shared node in our local wallet. And the second is the address. And then it is the amount of this node. And this is the transaction ID, and the next is 0. It is the index of the shared output. Because our shared transfer type supports at most 2 output, we use this field to mark different output. And then is unspent. Obviously, it is the status of this node is unspent. And the last is the memo. We just write. mint 1 million. Okay, this is a mint transaction. And before we next we will will show how to transfer. We will spend this mint to send it to a new shared address. But before we transfer, we should log out and log in with another public account. No matter you mint, transfer, or user better use different public accounts of privacy. Okay, let's go on. We list the shared node and list the shared address. Next, we will spend this node and send to the first shared address. We use the send shared TRC20 coin again. Under the first parameter from public amount, we set 0 because this is a transfer. There is no public input. And the next is the shared input number. We set 1 because we want to spend this one node. And then input 1. This field, we set the index of the node in our local field, local wallet. So we set 0. And then next, because there are only one input, so we can ignore the input 2. Next is the public 2 address, and also we set it none. And the 2 public amount we set it 0. And then is the shared output. The number of shared output we set it 1 because there is only one shared output. And next is the shared address. We select the first, copy it, and the next is amount. Amount we must be equal to the shared input. It's 1 million. 1, 2, 3, 4, 5, 6. And the last is the memo. We also set a memo. Transfer 1 million. And because there is only one shared output, so the shared address 2 amount 2 memo can be ignored. Okay. We input our password. This command will trigger the transfer function in our shared contract. Let's check this transaction by get transaction info by ID. Okay, the result is success, and we use list shared TRC20 node to show the receiving node. This is just a node we receive. And the index is first. And this is the transaction ID. And if you want to look at the spent node, you can use this command, but you should input a parameter. You can input it 1. This command will show all the nodes, no matter you spent or you have not spent. The first is the unspent one, and the second one is the spent one. Okay, my show is over. Thanks. If you want to use wallet client, you can refer to our GitHub. Okay, thank you.
Okay, thanks, Leo. It's really a great demonstration. Do you guys have any question regarding this part?
I do have one. Where is set the TRC20 ID? like the token that is being binding in the contract.
When you deploy the shielded contract, right?
I mean the public one, the TRC20 ID of the public key token. Where did you bind that in the shielded contract?
In this testnet, the TRC20 contract is deployed by ourselves. We just test for it. And if you want to use the TRC20 token in the mainnet, you should buy some TRC20 token, and also the related shielded contract should be deployed that you can use the shielded transfer.
So basically, every TRC20 token must have a shielded contract to operate with shielded transactions.
Yes.
It's 1-to-1. And where did you specify? I didn't see where did you specify the TRC20 shielded contract in the command lines.
This is just a wallet. The shielded TRC20 contract is deployed in our now test work and now net under sorry. And the code is in our tip.
So basically, the shielded contract that we're triggering now is hard coded in the wallet CLI that we're using, or in the config file or somewhere else.
So sorry, I can't hear clearly.
The shielded contract that we're triggering, the one that we're executing the actions, are hard coded in the wallet CLI, or is in the config file. Where do you specify the address of the shielded contract?
Okay, I understand. This is a wallet that you can connect, you can bundle all the shielded contracts and the TRC20 contract. This is not just we use this command, send the shielded TRC20 contract address to connect the TRC20 contract and the shielded contract. We can use different TRC20 contract and the shielded contract. And every shielded contract is related to one TRC20 contract.
So
okay, thanks.
Okay. Do you guys have another question before we close the meeting? Okay. If no, I think we can close the meeting now. The timeline and agenda of the meeting 10 will be updated on our GitHub after confirmed. We will also keep you updated in the Telegram channel. Okay, thanks everyone for coming. Thank you. Bye.
Bye.
Bye.